Welcome back, chemistry students. I'm Mr. Silverstein. Today we're going to get into part 3 of stability and bonding of concept 1. I'm going to share my screen. Make sure you're taking notes in your unit pack or in your spiral notebook. If you have any questions, make sure you email me and I'll get back to you quickly. These slides are posted on Google Classroom for you, and make sure you do the assignment at the back end. So, our big idea, of course, is why and how do elements form compounds in nature. And in this lesson, we're going to use an element's location on the periodic table to determine its oxidation number and bonding tendencies. So let's review. When atoms gain, lose, or share electrons in order to become stable, they form chemical bonds. An ionic bond forms when atoms transfer electrons in order to be stable, usually between a metal and a nonmetal. The result is the formation of ions. There are two kinds of ions. There's the cation and the anion. The cations are positively charged ions, atoms or molecules, that can give up or lose electrons, and those are usually metals. Anions are negatively charged ions, atoms, or molecules that will gain an electron. And those are usually nonmetals. And we saw the example looking at sodium and chlorine. Sodium had one valence electron to give up, so it was positive. Chlorine needed one electron to become stable, so it was negative. Now, on the ionic bonds, we're going to review that again. Remember, the ions are atoms or molecules that have a charge due to having lost or gained electrons. And I like to say not lost, but are capable of giving or receiving electrons. And so if we look back down here at magnesium, magnesium has 12 protons, which means it also has 12 electrons, but it's a period 3 element, so it's going to have 3 energy levels. The third outer valence electron shell has 2 electrons there that magnesium can give away in order to become stable. So it has a positive charge. Oxygen has 6 valence electrons, which means that it needs 2 to become stable. It's easier for oxygen to get 2 valence electrons than it to give away all of its valence electrons. So oxygen has a -2 charge. So cations are positively charged, anions are negatively charged. Now, what kind of ion will the lithium form? Well, lithium has 3 protons, which means it has 3 electrons. It has 1 electron in its valence electron shell. So it's going to be positive. So it's going to have to be a cation. And so lithium has 1 valence electrons that it will lose or give away in order to become stable, creating a cation with a +1 charge, also known as lithium +1 in a superscript. Now, if we looked at nitrogen, what ion will nitrogen form? Again, nitrogen has 7 protons, which means it has 7 electrons. There are 2 electrons in the first energy level, and there are 2, 4, 5 in the second energy level. So it's going to need 3. So nitrogen has 5 valence electrons, so it's going to need to gain 3 electrons in order to become stable, creating an anion with a -3 charge. So this would be shown as nitrogen, -3 as a superscript, knowing that it is negatively charged. So elements in the same group, and remember groups are the vertical columns on the periodic table, have the same number of valence electrons. Because of this, elements in the same group will form ions in the same way. And so all the elements in group 1 have one valence electron, so all of them will have one electron to give away to become stable. Therefore, all of the elements in group 1 have a positive 1 charge. And we call that charge the oxidation number. Make sure you highlight that. That charge is the oxidation number. So lithium will form Li superscript plus 1. Sodium, our friend sodium Na, will be Na plus 1. And potassium, which is K, will form K superscript plus 1. All of these elements each in the same group have the same number of valence electrons. Now, an oxidation number, and this is a key term for you, is the charge of an ion within a compound. And the oxidation number is written as a superscript to the right of the symbol. So group 1 elements, and you want to jot this chart down in your notes. Group 1 elements have one valence electron. It has a plus 1 charge. Group 2 have 2 valence electrons. They have a plus 2 charge. We skip groups 3 through 12 as those are the transition metals, and we'll get into those a little bit later. We then move over to group 13. They have 3 valence electrons. They have a plus 3 charge. Group 14 is a special group because it has 4 valence electrons, and it can either be positive or negative depending upon the formula that it's going into. Group 15 has 5 valence electrons with a negative 3 charge. 16, 6 valence electrons with a negative 2 charge. Group 17 has 7 valence electrons with a negative 1 charge. Let me go back to that for a moment. And remember, group 18 already has 8 valence electrons, so they are already stable, noble gases. So it's pretty easy to see which group elements are going to be able to give away or lose an electron, and which are able to receive or gain electrons. This is a great video for you to watch on how to find oxidation numbers. It runs about 6 minutes. You can run that on your own before you do your recap. So let's review. When atoms gain, lose, or share electrons in order to become stable, they form chemical bonds. Ionic bonds form when atoms transfer electrons in order to become stable, usually between a metal and a nonmetal. Elements in the same group have the same number of valence electrons, and because of this, elements in the same group will form ions in the same way. And the oxidation numbers are the charge of an ion within a compound. And a neutral compound will always end up having a charge of 0. Now, on this assignment, you're going to open up assignment L4. There is a Google slide there. You will enter the information. You're going to practice ionic bonding. You'll need your periodic table so you can get what element number it is, the number of valence electrons, and its oxidation number. And then you're going to need to enter into there what kind of ion it will form. It'll either be an anion or a cation. Let's stop sharing. Well, that's all I have for you today. Make sure you update your notes, watch the supplemental video, and complete the practice. If you have any questions, make sure you email me and I'll get back to you quickly. Other than that, you guys have a great day.